Let us discuss about kinematic equations. And when do we use these equations in a given problem? So, how do we really analyze a problem in kinematics? So just consider these two cases in solving kinematic equations. So we all know that kinematics is the study of motion. So it is a study of moving objects. So when an object is moving or an object is in motion, there are just two possibilities that we can describe the motion of this object. It's first, the object can move in constant velocity, or the object can move in constant acceleration. So if you encounter a problem, the first question that you have to consider in mind is the situation of the object. Is the object moving in a constant velocity, or is it moving in constant acceleration? Because this will determine what equation, in what group of equations we can choose or in solving the problem. So what does it mean that an object is moving in constant velocity? If the object doesn't change its velocity from its starting point up to its final position, its final point, then we can say that it is in constant velocity. Like for example, if a car is moving from the starting point to 10 meters per second and it doesn't change its speed up to its final point, it is still 10 meters per second, then we can say that the car is moving in constant velocity. If this is the case, we can only use one equation, and that is our equation for velocity, where velocity is equal to displacement over time. Your displacement can be x or it can be y, so you can just replace it by x over t or y over t. So this is just the equation that we can use if the object is in constant velocity. But when the object is in constant acceleration, we cannot directly use this equation. There, now we will introduce the four basic kinematic equations. So we have four equations that we can choose to if the object is in constant acceleration. Let us derive those equations. So let us start from the acceleration equation. From our acceleration equation, knowing that acceleration is the change in velocity given a period of time, acceleration is equal to v final minus v initial all over t. So we can derive equation 1 from this by just cross multiplying. We'll have vf minus vi is equal to a t. If we will derive again for v final, we'll just transfer v initial to the right side of the equation. We will have vi, v initial plus the product of acceleration and time. This is now your equation number 1. Okay, so this is equation number 1 for the 4 basic kinematic equations. For equation number 2, we can consider our equation for constant velocity. According to our equation for constant velocity, velocity is equal to displacement over time. So I told you earlier that we can replace d by x or y depending on the motion of the object. For example, if it is horizontal in motion, we can replace the equation velocity is x over t, or if it is in a vertical motion, we can have v is equal to y over t. But in case number 2, if the body is moving in constant acceleration, we cannot directly use these equations because it has already 2 velocities, because it is accelerating. So we have initial velocity and final velocity, but we can just have the average of those velocities. So we are not just dealing with one velocity, but we are dealing with 2 velocities. So we can just have the average velocity all over x over t. Let's say x over t if the object is moving horizontally. By cross multiplying in getting the displacement, we'll have x is equal to average velocity multiplied by time. Now, how do we get the average of 2 quantities? Like, for example, average velocity, and we have 2 velocities, initial velocity and final velocity. Therefore, the average velocity is just adding the initial velocity plus final velocity all over 2, or this is 1/2 times the quantity v initial plus v final. Now, substituting it to our equation, in this equation in getting the displacement, you will have now x, the displacement, is equal to 1/2 times the quantity v initial plus v final times time. This is now our equation number 2. Okay, x is equal to 1/2 times the quantity v initial plus v final times time. So this is our equation number 2. So we have the first equation, which is v final is equal to v initial plus a times t. Then the second equation is x is equal to 1/2 v initial plus v final times t. So for the third equation, we can just substitute equation number 1 to equation number 2. From equation 1, we have equation 1 v final is equal to v initial plus at, and equation 2 we have x is equal to 1/2 times the quantity v initial plus v final times t. If we will substitute equation 1 to equation 2, we'll have x is equal to 1/2 times the quantity v initial plus the quantity. Okay, let us substitute now this equation 1 to v final here. We'll have v initial plus 80 times time. Okay, by simplifying the terms inside the bracket, we'll have 1/2 times the quantity vi plus vi is 2vi plus 80 times time. Now, by further simplifying this equation, by just distributing 1/2 and time in the equation, let's say, let us first distribute 1/2. 1/2 times 2vi, 1/2 times 2 is 1, so we'll have vi plus 1/2 times 80 is 1/2 80, the product of acceleration and time, times t. If we will again distribute t to this term, we'll have v initial times time plus 1/2 a t times t is t squared. Now, this equation, displacement x is equal to the product of v initial times time, or vit, plus 1/2 at squared. This is now our third equation for case number 2. Equation number 3. Equation number 3, the third equation that we can use if the object is in constant acceleration. For equation number 4, for the fourth equation, for equation number 4, from the acceleration equation, we have acceleration is equal to vf minus vi all over t. Let us get t, the time, from this equation. We'll have time is equal to vf minus v initial all over acceleration. Now, substituting this equation t, for equation for t, to our equation number 2. So from equation 2, substitute t to equation number 2. So from equation number 2, we have x is equal to 1/2 times the quantity v initial plus v final times t. So we will replace this t by this equation coming from our acceleration equation. So it will become 1/2 times the quantity v initial plus v final times t, which is equal to vf minus vi all over a. Now, simplifying these terms, we will have this will now become vi, the quantity vi plus vf times vf minus vi all over the denominators 2 and a, 2a. Okay, so this is x. So we can simplify the numerator, this term, by using the FOIL method that we have learned in our algebra. If you can still remember, first term, outer term, inner term, and last term. That's why we call it the FOIL method. So by multiplying these quantities, we'll have the first term, Vi times Vf, Vf, the outer term, Vi and negative Vi, therefore it is negative Vi squared, the inner term, Vf and Vf, plus Vf squared, and the last term, Vf and negative Vi, is negative Vi Vf. Our denominator, of course, is 2a. So if you'll notice, we can cancel Vi Vf. This is a positive one and the other is negative, so we can just cancel it out. We'll have now the equation. Simplifying now our equation, we'll have x is Vf squared positive minus Vi squared all over 2a. So this is your x. So by cross multiplying, we'll have Vf squared minus Vi squared is equal to 2ax. And simplifying again, we need to get Vf squared. We just have to transpose Vi to the right side of the equation. We'll have Vf squared is equal to Vi squared plus 2ax. So this is now our equation number 4 for the case of constant acceleration. So Vf squared is equal to Vi squared plus 2ax. So we have derived the 4 basic kinematic equations. So let's summarize our equations again. With our discussion again, we consider if we will encounter, we'll solve problems. The first thing that we have to ask our mind is that, is the object moving in constant velocity? Is it moving in constant velocity or in constant acceleration? If it is moving in constant velocity, like what we have discussed earlier, we'll just use the equation velocity is distance or displacement over time. We can just replace d by x or y depending on the motion of the object. We can replace it by x if it is moving horizontally, or y if it is moving vertically. Okay, but in constant acceleration, we have derived the 4 basic equations. The first equation, Vf is equal to Vi plus at, the product of acceleration and time. We have the second equation, x is equal to 1/2 times the quantity Vi plus Vf all over t. Then the third equation, we have x is equal to Vi t plus 1/2 at squared, and the fourth equation is Vf squared is equal to Vi squared plus 2ax. So these are the summary of our equations in kinematics in 1 dimension. So again, the first thing that you have to ask yourself when you encounter a problem is the problem in constant velocity or in constant acceleration? If it is in constant velocity, you will just be using this equation. Velocity is distance, displacement over time. So this is just the equation that we have to use. But if it is in constant acceleration, then we need to choose among these equations. Okay, so we need to analyze the problem if what equation from 1, 2, 3, 4, equations 1, 2, 3, 4, what equation do we have to use in solving the problem. Okay, so but you can just derive other equations from these four basic kinematic equations. But there are also problems that both cases are involved: constant velocity and constant acceleration. So if we encounter problems involving constant velocity and constant acceleration, then you just have to relate the variables, analyze the problems, and maybe you can relate two variables, equate two variables involving these equations. So you just have to practice more problems in analyzing the situation, the given problem. Basically, these are the equations that we can use in solving kinematic problems. So hopefully you can familiarize yourself with these equations. So this is just a few equations that we can use. So hopefully it would help you better understand, analyze problems in kinematics equation, kinematics in one dimension.